How we doing, guys? It is Thursday, April 23rd. Today we are going to talk about actually a subject that you guys have already learned. All right, so we're going to fly through pretty quick today. It is something called the Pythagorean Theorem. All right, and just to show you, just real quick, you learned it last year in your Advanced 2 class. All right, so if we look in here, here it is. In Chapter 7, you learned real numbers in the Pythagorean Theorem. All right, so you've learned it. But it is a really, really important rule in math and in geometry. Okay, so we obviously should review this before you move on to geometry next year. Okay, so just so you know what all of this kind of means. So where did it come from? So Pythagoras was a Greek mathematician and philosopher who discovered one of the most famous rules in mathematics. In mathematics, a rule is called a theorem. Okay, so that's where they got the name. So the rule that Pythagoras discovered is called the Pythagorean theorem. All right, now let's take a look at what is that rule exactly. All right, so first things first, we need to know that this rule, this theorem, can only be used when we are looking at a right triangle. Okay, so key idea, sides of a right triangle. The sides of a right triangle have special names. Okay, so I will be using these names throughout the lesson. So hopefully we're listening to our vocab here. So we have two legs of a right triangle. The legs are the two sides that form the right angle. Okay, so what they're saying is these two lines, these two sides come together to form the right angle here. Okay, those are the legs. All right, and the last side is called the hypotenuse. So the hypotenuse is the side that is opposite of the right angle. And something else we should know about the hypotenuse is, let's look at our study tip here. It says in a right triangle, the legs are always the shorter sides and the hypotenuse is always the longest side. Okay? Makes sense because it has to get from one end of one leg to the end of the other leg. All right, so it's always going to be the longest side. It's called the hypotenuse. All right, so we kind of label these things. All right, one of the legs we call A, the other we call B, and the hypotenuse we call C. All right, and the theorem is, you're probably going to remember, it's pretty simple. It says in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So actually, this time algebraically, it makes way more sense to read it like this. It means that a squared plus b squared, the two legs squared and added together, equals c squared, the hypotenuse squared. Okay, so that's the theorem right there. Probably want to write that down because we're going to be using it. All right, we're going to be using it to meet this learning target today. Okay, learning target today is I can use the Pythagorean theorem to find a missing side length of a right triangle. Okay, so that's what we're going to be doing. We're either going to be finding the hypotenuse or we're going to be finding one of the legs. And we can use that theorem or that rule to do that. Okay, let's look at one example. First example is finding the length of the hypotenuse. All right, so when we're missing what c equals, this is the most basic type of example, okay, because it's the fastest. This is the fastest type of example to find our missing side length. All right, so when we're finding the length of the hypotenuse, we are looking for what c is. Okay, now there's your theorem. Now I want to show you something that's pretty important is the legs go hand in hand. What I mean by that is like 8 could have been plugged in for A and 15 could have been plugged in for B and you'll still get the same answer. Okay, so the legs go hand in hand. It doesn't really matter where the numbers go when we're looking at the legs. We just have to make sure that we are plugging the numbers into the correct place. So if these are the legs, they need to go in for A and B, but it doesn't matter which one goes where. Okay, so we're looking for C. All right, so let's just say the book called 15 our A value and 8 our B value. We plug them in. We now have to square those numbers. Okay, so 225 and 64 is what we get. And then we want to add them. We want to add them to get what C squared is. Okay, so now I'm left with this, right? But it's not asking me what C squared is. It's asking me what C is. Okay, now we kind of learned this. How do we find what c is if we know what c squared is? We take the positive square root because we're talking about a distance, right? We're talking about a length. So only the positive square root makes sense. Okay, so we take the square roots of both sides and we get c equals 17. All right, so we found our hypotenuse is 17 feet. Okay, should make sense. Pretty simple. Another way to really fast just make sense of your answer. Remember, the hypotenuse is supposed to be the longest side. Okay, so 17 is longer than 15 and it's longer than 8. So our answer makes sense. Okay, so that's just a quick way we can always check our answer too. Let's try another one. Same way. All right, we're finding the hypotenuse again. All right, so what I'm going to do is I'm going to write this one out for you. All right, I'm just going to say I'm going to call 3 inches my A value and 4 inches my B value. Remember what I said? It doesn't matter, really. I could have put 4 in for A and 3 in for B. It doesn't matter. So using my theorem, 3 squared, so A squared plus 4 squared, so B squared, is going to give me what C squared equals. Okay? A squared plus B squared equals C squared. All right, now I got to square these numbers next. Okay, we don't want to add and then square, right? Order of operations. So 3 squared gives me 9 plus 4 squared gives me 16 is going to give me, remember what C squared equals. Doesn't give me my final answer yet. So I'm going to put these together. So 9 plus 16 gives me 25 equals C squared. That's not my final answer. I want to take square roots at the end. Okay? And I'm going to get 5 equals C. So 5 is my hypotenuse. I can say that this length is 5 inches. All right. So again, finding the hypotenuse is pretty basic. We just take the numbers, the legs, and we square them and add them together and then take the square root at the end. Okay. Why don't we have you guys give this a shot? So why don't we try these two quickly? So at this time, pause your video, and when you come back, answers will be up. Okay, so here's the deal. Number 1, we get 25, pretty straightforward number, right? Number 2, what you should be noticing is when you take 10 and square it and take 7 and square it and add the numbers together, you get 149, right? So what we could do is we could just round that number to the nearest tenth, and that's what you're going to do when you don't end up with a nice number with a perfect square when you do your practice later, all right? So we want to round this number to the nearest tenth is fine, okay? All right, example 2 now, all right? When we're missing a leg of the triangle, okay? How do I know I'm missing a leg, right? Well, it tells me that I'm looking for B, all right? B is one of my legs. Also, these sides right here and right here come together to form the right angle, okay? So I know I'm finding a leg. So what I have here is I know that this has to be A because, again, it's one of the sides that comes together with B to form the right angle. So this has to be my leg, and this has to be my hypotenuse. Another way to kind of look at this, sometimes it helps. If you know where your right angle is and you draw an arrow from it to its opposite side, you're always going to find the hypotenuse. Okay, so that's a little trick. So again, side opposite of the right angle will always be the hypotenuse. Okay, so what I know right now is that I have an A value of 3.5. I'm looking for my B value, and I have a C value of 6.5. All right, so let me just show you what the book does here. So there's your theorem again, your rule. They are substituting. So substitute 3.5 for A and 6.5 for C this time. So there's a different step at the end. So we have to square them. All right, that gives me 12.25 when I square 3.5, and 6.5 squared gives me 42.25. So what I have to do this time is I need to isolate B squared right now, okay? I don't just add the numbers together and say, all right, I got my answer. I actually have to subtract my other leg from the hypotenuse, okay? So again, we want to isolate B squared this time. When we're finding the leg, we have to isolate it first isolate that variable first. All right, so we subtract 12.25 from each side. Now that leaves me with b squared equals 30. Okay, and now I can take my square roots. All right, on both sides to get rid of the squared. Okay, so what they say here, they round to the nearest tenth. They're saying the length of the leg is the square root of 30, which is approximately 5.5 kilometers. Okay, so that's what we do when we're finding a leg. All right, let's try another one. I'll show you one last one and then have you guys give this a shot today. So, all right, we've got 9.7 as our hypotenuse. Here's how I know. If I draw this arrow from my right angle, I see my hypotenuse. All right, so this is C. Okay, I'm looking for A, so what's left? This has got to be B. Let's say B equals 6.5 meters. Okay, so I know I'm looking for A. I know my B value is 6.5 and my C value is 9.7. All right, so I'm going to write out my equation of A squared. What I'm looking for is A plus B is 6.5 squared equals 9.7 is my C value squared. All right, so now I'm going to take 6.5 and square it. I'm going to rewrite my A squared plus 6.5 squared gives me 42 point equals. I'm going to take my 9.7 and square that. Gives me 94.09. Okay, now I have to isolate A squared, remember. So I'm going to subtract right now 42.25 from both sides. Which is going to give me A squared equals, let's see, 94.09 minus, that gives me 51.84. And now I got to take the square root of that number. Okay, so on my calculator, 51.84. And that leaves me with A equals 7.2 meters. That's my final answer. Okay. So, that's it. That's it for the lesson right there. So, again, there's kind of some different steps that you need to take when finding the hypotenuse, and when you're finding one of the legs. Okay, but that is the lesson. That's just should be review for you guys from last year. All right, and at this point, you are going to go into big ideas and practice this. So I think there are 7 questions in there for you to practice today. So at this time, go to big ideas, go to 10.3 practice assignment, and complete that today. And tomorrow you'll have an IXL benchmark on this to end your week. Okay, so hopefully that made sense. Email me if you have questions or ask in the discussion thread. I will talk to you guys tomorrow.